Thus far, we've been displaying our dates using the default datetime format. However, it wasn't the most pleasant thing in the world to look at. Thus, KQL includes a command called format underbar datetime that lets us take a column, in this case time generated, and reformat it in different ways. Here in this simple example, I'm going to run a query, and I'm going to include my format datetime with multiple formats. In the time generated one column at the bottom, you can see it used the single Y followed by a capital M, capital by a lowercase d, to give me the year, month, and date, and as few digits as possible. The next example had 4 Ys, 2 Ms, and 2 Ds, so that we got the full year, month, and date, with zeros if either one of those was a single character. In the lower 3 examples, we are including the time along with the date. In the first one, which displays in the time generated 4, we used lowercase h's for the hours. This returns an hour in the range of 0 to 12, so we have to include the TT at the end for the AM or PM indicator. In the next row, time generated 5, we're using capital H's, which means our time is going to be in 24-hour format. Thus, there is no need to use the TT. Finally, in the last example, we'll see that I can actually go down to the millisecond level. Here you can see I went down and time generated 6 has 0.3100 milliseconds associated with it. Below this example, I have a little chart with a supported syntax. Whenever you see a character occur once, that means we're only going to put one number in that position. So if the date is the 1st, you're only going to see the number 1. If I have 2 letters, for example, DD, then I'm going to get 2 characters for that date. So the first would come out to be 01. Now when it comes to my letters, capital M indicates the month. This is an important distinction because if it sees lowercase m's, as you can see in this lower chart, lowercase m's indicate minutes. So it's very important you keep these two distinct. As I mentioned a moment ago, lowercase h's indicate the hour in 1 to 12, whereas uppercase is 0 to 24 for what they often refer to as military or 24-hour time. If you're using the lowercase h's, you should include TT to indicate whether this is AM or PM. The hours and seconds can also be used with the format timespan command, which we'll see in just a moment. In addition to hours, minutes, and seconds, we can also include the letter F for subseconds. A lowercase f will always display a value of 0, whereas the uppercase will only display a number if there's actually a subsecond value in that position. The number of f's we include indicates the precision all the way down to millionths of a second. So let's come look at the format timespan that I just mentioned. In this, I've got my counter values, time generated, and I want to include the time of the day as a formatted timespan. Because a time generated is a date data type, we have to convert it to a timespan data type. So let's actually run this, and you can see that the time of day was generated as 3 o'clock, 54 minutes, 41 seconds. This is a little bit of a misuse of the format timespan. I did this though so I could illustrate the toTimespan function. Timespans are typically the result of some sort of a date math. In this next example, you're going to see I'm taking a time generated and I'm using dynamic ranges for the between 7 days ago and 2 days ago. We're just going to get a random 100 rows. And my new column, time generated, is going to be now minus the time generated. This date math is going to return me a timespan data type. I can now use this with format timespan. Let's run this query, and you're going to see the different timespan formats that are returned. Because of the time of day it is, all of these are going to return 12 hours 57 minutes. The difference is going to be in the number of seconds that's returned. So you can see these all pretty much come back to 12 hours 57 minutes and 4 seconds ago. In addition, we can also use Fs for giving us sub-second values. In this example, I'm going to create a timespan column named TimeGen, and then I'm going to format it with different levels of precision by using a different number of Fs in the format timespan parameters. So here you can see at the bottom my time generated 1, time generated 2. You can see as I drill down deeper and deeper in using my Fs as to the level of precision that I'm getting out of this particular format timespan. Whatever it is you need in terms of precision, you can easily accomplish up to the millionths of a second.